Welcome to our project tutorial on 32-bit multi-cycle CPU in Verilog. I'm Prabhat Bhatti, and I'll be presenting you with our source code. So let's break down our source code. Several inputs such as clock signals, enable signals, read enable signal, write register address, read register address, and write data. It provides several outputs including the PC counter, the instruction register, and memory register, and various other registers. So we have several parameters defined such as R format, LW, SW, BEQ, and so on. The module contains a test program which initiates a different sequence of instructions such as loading and storing, branching based on the conditions, and performing arithmetic operations. Now let's dive into the heart of the module, which is the clock. This block is triggered by a rising edge of the clock and the signal and the controls of the execution and based on the current state of the CPU. In the fetch state, the instruction pointed by the program counter is gathered from the memory and stored in the instruction register. During the decode state, the operands are gathered from the register file and based on the instructions. Next, in the memory state, memory-related operations such as loading or storing occurs. And lastly, the write back state, results of the operations are written back to the appropriate registers. Next, I would like to pass it on to Angelo to do our test bench.
Hi, I'm Angelo Dafton, and I'll be going over our test bench code for the project. So first, we can start by defining our clock signal and optional reset signal. And basically, these signals are here just to help control the timing and initialization of our CPU module. Then we can instantiate our CPU module, CPU1, and we can then connect it to the clock and reset and all other output signals, such as PC or IR. And then we can now look at the initial block. So here we can apply an optional reset signal to initialize the CPU. After that, we can then load the machine language instruction into the memory array. So after doing the initialization, we provide a clock signal for a certain number of cycles to simulate the passage of time. And basically after each cycle, the clock signal toggles and it simulates the operation for the CPU. Then finally, we can display the final outputs of the CPU after the simulation is complete. And in doing this, it basically allows us to observe the state of the various registers and signals at the end of the simulation. Thank you. Now I'll be passing it on to Mustafa for the simulation.
Hello, this is Mustafa Abu Shaban, and for the project I'll be showing how to do the Verilog compiler and elaboration as well as the simulation. So first of all, we go to the source code and then tools, and we're going to go to Verilog compiler, press OK, and it's successful. Next we're going to do the test bench, same thing over here. We're going to go to tools, Verilog compiler, and then press OK. And then the next thing is we go to the worklib documents and see what we got, and we're going to elaborate from there. So we're going to press on the source code and go to tools, elaborator, and as you can see, it's successful. And then for the test bench, the same thing, elaborator, and that was successful as well. After that, we're going to go to the snapshots and take the test bench snapshot and go to tools, and we're going to simulate it. We're going to press OK. It's going to take a while to simulate. Here we already have it previously simulated, so I'm just going to open that one. And we're going to have selected all the instructions and show the waveforms of it. So here's all instructions selected, show the waveforms. And as you can see, it was not the ideal waveform